Hi, good morning everyone. Following the lecture series on green technologies, I will be concentrating some basics on availability and need of conventional energy resources. Myself, Dr.S.Prakash, Professor EEE Department, Bharat Institute of Higher Education and Research. Let me move on to the availability and need of conventional energy resources. Under this topic, we will be seeing major environmental problems related to the conventional energy sources, right. Then future possibilities of energy need and availability. Non-conventional energy sources such as solar energy and solar energy conversion technologies and devices, then the principles, working and application can be discussed on this topics, right. So the major environmental problems related to the conventional energy resources, right. See why we move to new technologies, why we move to new process is that we have some issues related to the conventional energy technology, right. So all energy sources have some impact on our environment. For example, if you see taking the fossil fuels, coal is going to be a problem, right. Coal is the first energy, so we used it as a first energy source, right. From the coal we found steam engines, right, by James Watt. With that the transportation has started, right, through rail engines, etc., everything. Then we went for natural oil, right, that is the crude oil. Then we have a refinery industry which will just go on refiner under various stages. It will be refined and you will get oil, petrol, diesel, gasoline, etc., everything. So then the natural gas, right. In all these fossil fuels, in one or another way they are going to create some environmental issues, right, to substantially more harm than renewable energy sources by most measures, that including air and water pollution, damage to public health, wildlife and habitat loss, water use, land use and global warming emissions, right. So these were the problems related to the fossil fuels, right. Next, future possibilities of energy need and availability, right. So we want to know, see, when we are saying the existing energy source is going to be a problematic one, right, then we should focus on the future energy needs, right. So how the future energy will be. However, you can see renewable sources such as wind, solar, geothermal, biomass, hydropower also have environmental impacts, but some of which are significant and some of them are not that much pollutant one. The exact type and intensity of environmental impacts varies depending on the specific technology used, the geographic location and a number of other factors. By understanding the current and potential environmental issues associated with each renewable energy source, we can take steps to effectively avoid or minimize these impacts as they become a larger portion of our electric supply, right. You can see the current and potential environmental issues only, right, talks about the need for the new energy resources, right. So we can take steps to avoid or minimize the impacts, right. So we will move to next slide. Non-conventional energy sources. Non-conventional, that is renewable energy, are sources that are continuously replenished by natural process, right. Non-conventional energy are sources that are continuously replenished by natural process. Most of the renewable energy comes directly or indirectly from sun or wind and never get depleted, right. Of course we know that, right. The energy from sun or wind will never get depleted, so we try to move over that. renewable energy sources are essentially flows of energy, right? They will have continuously, we will have that energy, right? Coming to that, the first one is about the solar energy, right? So we will be seeing most renewable energy sources, but there is some bound on that, right? So wind energy, it's possibly with a geographical location. Similarly, if you see in hydrothermal or hydro power, right, where you want water, the annual rainfall, then the perennial availability of the water resource, you have to construct a dam, and all these things makes hydropower also to be somehow yeah, harder one, right? Then about geothermal, where you want to dig a hole under the earth crust, then you have to utilize it, so that's also not up to the mark. Then biofuels and bio, right, that is systems, which is also somehow harder than this availability of solar and wind. So first we try to concentrate some more on the solar energy. So solar power, that is here the environmental impacts associated with the solar power can include land use and habitat loss, water use, and the use of hazardous materials in manufacturing. Though the types of impacts vary greatly depending on the scale of the system and the technology used, PV solar cells or concentrating solar thermal power plants are mostly used. We used to tell it as PV cell, right, photovoltaic system, or CSP, concentrating solar thermal plants. So solar energy conversion, it describes technologies devoted to the transformation of solar energy to other useful forms of energy, including electricity, fuel, and heat, right? It's solar energy is not going to be a one-to-one conversion. Instead of that, it can be converted to any form of energy. Probably you can have an electricity, fuel, heat, etc. anything it can be converted. And you want to know the basic thing, India is blessed with more number of sunny days when compared to any other countries, right? Our geographical location itself meets the requirement such that we have more number of sunny days. So when we have more number of sunny days, then why you have to worry? We will start planting the solar farms, we get energy, renewable energy very easily, right? So that is what an added advantage to the Indian peoples. It covers light harvesting technologies including traditional semiconductor photovoltaic devices, emerging photovoltaics, solar fuel generation via electrolysis, artificial photosynthesis process, and related forms of photocatalysis is directed at the generation of energy rich modules, right? So it doesn't mean you have only a PV cell and convert it into some energy, DC energy is developed, then with the help of a battery you can store it, you can reuse it with the help of an inverter or whatever it may be. You have many type of process under solar energy conversion, where we are working on that for even more than 100 years the process goes on. So we will have these advantages, right? Coming under the solar energy and linking it with the electricity production. So photovoltaic PV use silicon solar cells to convert the energy of sunlight into electricity. Okay, it converts the sunlight into electricity. That is the major function of the PV cell. We all know about that. So this PV uses solar cells to convert to electricity. It operates under the photoelectric effort, which results in the emission of electrons, right? Concentrated solar power uses lenses or mirrors and tracking devices to focus a large area of sunlight into a small beam, right? So I will show you some preferable examples so you can understand about this PV cell, then similarly about the CSP, etc. everything. Solar power is anticipated to be the world's largest source of electricity by 2050, right? So we anticipate it is going to be the largest source of electricity by 2050. solar power plants such as Evan Park Solar Power Facility in Mojave Desert produces over 392 megawatt of power, right. Solar projects exceeding 1 gigawatt, right, 1 billion watts are in development and are anticipated to be the future of solar power in the US. Right, now you want to see the diagram of the setup of a photovoltaic collection array. Right, you can see the setup of a photovoltaic collection array. You can see the PV cell that is going to be generating the DC voltages, right. Then you will have an inverter and transformer, and then you will have a switchboard where the power can be transmitted. So, the major source for all these solar panels is going to be the energy from the sunlight, right. This is how the setup will be, right. It is sent to the grid. The heat collected by the sun is highly intensive and radioactive. The sun bombards the earth with millions of charged nanoparticles with an immense amount of energy stored in them. Right, knowing about the thermal energy from the sun, this is the case. This heat can be used for water heating, space heating, space cooling, and process heat generation, right. So, in India we have more number of sunny days, we go for space cooling system, right, whereas in Commonwealth countries they have more number of cold days also. So, they may go for a space heating system also, right. Then is thermal energy. Under the thermal energy, many steam generation systems have adapted to using sunlight as a primary source for heating feed water, a development that has greatly increased the overall efficiency of boilers and many other types of waste heat recovery system. So, the solar cookers, that is the different phase of using the solar energy. It uses sunlight for cooking, drying and pasteurization, right. So, solar distillation is used for water treatment process to create potable drinking water, which has been an extremely powerful player in providing countries in need with relief efforts through the use of advanced technology, right. So, with the available thermal energy, right. So, what are the things we can develop with the help of the solar, that is all discussed here. Then you can see the next way how we see the solar energy is about the economic development. Solar energy conversion has the potential to be a very cost effective technology, right. It is cheaper as compared to non-conventional energy sources. The use of solar energy help to increase employment and development of the transportation and agriculture sector, right. So, it is not that much a costlier one, right, but it may also be somehow more cheap, right. So, you can see that. So, the solar installations are becoming cheaper and more readily available to countries where energy demand is high, but supply is low due to economic circumstances. A 1 gigawatt solar power plant can produce almost 10 times as much power as a fossil fuel combustion power plant that would cost twice as much to establish. So, you can see the difference, right. So, how much it is going to take, right. A 1 gigawatt solar power plant can produce almost 10 times as much power as a fossil fuel combustion power plant that would cost twice as much to establish. So, you can feel the difference. I will tell you some more things also on this. Following this, you can see we rightly the community is interested to have standalone power plants, right. See, as you see, I don't want to have a very big solar farm or a very big structure to put and get a power and right. Instead of that, if I design any standalone system, right, then I may find it more useful, because all of us we need portable systems, right, to be installed and it can be used, right. So we go for more number of standalone solar applications, right. So solar power plants have been projected to be the leader of the energy production by the year 2050, right. So by year 2050 you all will have renewable energy sources, right. That solar will be leading in power sector. Solar energy conversion, rural energy access, then also in community solar, we can discuss some examples of solar energy conversions with the students, right. So I feel that will be more better than going on talking something. So we will see directly some of the photovoltaic systems, applications, etc. Using the sun to generate electricity, that is the PV system, right. So then you can see the main application areas, you will be having it as off grid and on grid, right. We will be seeing it as an off grid and on grid. So under off grid, where and all you can use the solar system. Of course, this is a very important one to be discussed, because you can teach to your students, or the students have young mind, they have so many ideas. And the first one is about the water pumping system, right. You can see the first image, I will move the pointer. Then second one is about the space, right, where it is used in satellites. And then third one is about the telecom, and then fourth one is solar home systems. You can see this, fourth one is solar home systems. So concentrating on this only, I am telling we should go for more number of standalone systems rather than having an integrated system, right. Then main application areas where we are going to have a grid connected system. This example is off grid, individual, right. And here you can see some of the examples as grid connected one. The first one is a residential home system, where the rating is about 2 to 8 kilowatt solar power plants are connected. Then next to that is commercial buildings, right, where it is about 50 kilowatt, right. The power capacity, the power handling capacity is going to be up to 50 kilowatt. Then next one is the PV power plants, it is about greater than 100 kilowatt, right. That is these applications are grid connected applications, right, where you can connect it directly to the grid. It is synchronized in such a way that when the power is needed, it will be utilized by the owner or the plant where it is installed. If not, the unutilized power can be directly sent to the grid, and which can be used by some others, and the person who installed this will be paid according to that, right. So now I will try to show some examples which I have taken from Google for you, right. So you can see this is a place like a forest, right, on a planet where more than 2 billion people have no access to electricity. So PV systems can provide power for many uses. You just see the image, right. So you have more than 2 billion people, the past data, it is a past data which says more than 2 billion people have no access to electricity, but PV systems can provide for many uses as such, right. So we will see the examples one by one. Photovoltaic power is ideal for remote applications where other power sources are impractical are unavailable. You can see in the image a location like Himalayas, right, where it is very tough for an on-grid system or carrying an power through the cable. Instead, you can use very easily a solar panel as such. So, that can be taken as a very best example, right. We will move to the next slide. So, this is a mountain hut in a very remote area of France, which uses photovoltaic to generate power, right. Sir, you will be having in a hilly area, right, that we will be having some houses, or you will be having some religion, churches, temples, etc., everything, where we cannot get an on grid, or you cannot carry a power line for such a long distance, right, as because geographically disturbed. So, you can very easily go for this system, right. And then next is a lighthouse along the coast of Africa. Before this PV system was installed, the lighthouse relied on bottled gas for power, right. A system that required constant maintenance and permanent staff on site, right. You will be having a bottled gas for illuminating the lamp. This is on coast of Africa, where the light will be glowing all over the night, right, for the all the ships to track or to guide the ships, right. But before the impact of the bottled gas plant, nowadays we have the PV system is installed, where the maintenance is going to be very easy, right. Then next is this is a live example, a standalone PV system in rural Spain. This system consists of a 900 watt PV array with inverter and batteries. Here more than 60 rural homes in this mountainous area have been electrified with the photovoltaic system. Okay, you can see this. The picture shows you how the geographical location is, right. In such a case, as the day is going on, right, you cannot even live without power also. So, it is very easy for us to have a PV system in this area, and this is going to be a standalone PV system. So, already I discussed that a standalone PV system is more advantageous than other things, right. The next you see the another example. This is PV power for offshore navigational aids, eliminates trips to and from shore to refill generators with fossil fuels. I hope so you can understand this offshore navigational aids, right. Here this navigational aids eliminate trips to and from shore to refill with the generator. That is going to be the most important one, right. So, when the electric generator is used or any diesel generator is used, then it has to come to and fro to refill the generators with the fossil fuels. That is also the case. So, these things can be eliminated easily by using a solar PV system. Then next, this is solar powered water pumps are very efficient and cost effective in agricultural applications. Yes, right. So, you are going to have a very big farmland. In the very big farmland, the only initial investment is keeping the PV and selecting a suitable motor which is going to run with the help of this PV. That is going to be the only system, or otherwise, right, there is no such big maintenance on this system. So, the motor once when you get maximum power which starts by 10 AM in the morning, then it may go up to 3 PM, right. So, you can run the motor all the times, right. So, the water can be fed to the plants, right. So, the yield will also be good, right. So, it is absolutely free. You can see this when you have any live farm, then you can experiment it and you can see the advantages, right. Another farm application, keeping animals where they belong behind PV electrified fence charges, right. It is not so much dangerous as it is not using the conventional electricity, it is a PV electrified fence charges. So, that can also be done, right, even though the application is somehow tricky, but it is done, right. Then PV powered street lights like these in a rural town help contribute to the safety, security and general standard of living in remote areas all over the world, right. So, you can see the remote areas in all over the world can use this PV powered street lights, right. It comes into your mind, of course, this will work out. Then the lamp in this PV powered insect trap comes on automatically after sunset, right. It attracts insects which collide with the metal grid and drop into the receiver below. So, it is like a simple, a very simple insect trap, right, which is also activated here. Then next is PV applications include lighting for remote signs like this outdoor board along a highway. You can see this is an highway outdoor board, right, where the signs they can use the power from the PV cells instead of getting power from any grid system, and to pay for the electricity, everything can be eliminated in this structure. This is offshore navigational aids which require little maintenance, can withstand harsh storms and cut down on the cost and pollution of battery replacement and disposal by using PV for power. So, this is an offshore navigational aids, right, for that also it is used. Then highway directional signs can use PV systems, right. So, this is also another important application, right, which expense of excavation to extend electric lights to the signs as well as the cost of maintaining the electric line. Similarly, the maintenance of the bulb and etc. everything, right, you can make the PV system to be installed and it can be effectively used in these examples. So, PV is an excellent source of power for battery charges for boats, vehicles and equipment. So, the solar powered charger assures that the battery is charged and ready for use even if the boat or vehicle has sat for a long time and the battery has discharged. You can see in this, right, we can use the PV panels to charge the batteries, right. So, this is also going to be an essential one. Then campus, right. So, when you are in a holiday mood, campus can use PV in remote areas to provide power for lighting, appliances and other uses. You can see the diagram which show you can see the picture, right, which shows you the vehicle, right, then the panel which is in the top of the vehicle, which also gives the power supply which can be used for your entertainment. Right. In many cases, it is more cost effective to install a PV system than pay the cost of having the utility company extended the power lines to the home, right. So, it depends on the state to state as well as countries to countries decision, right, to have which system. In such a case, they are telling even a PV system can do more better. That many utility companies are turning to a large PV systems to help meet peak power demand and reduce the need for building new power plants, right. So, you can see some new power plants, right. You have plenty of panels, all are connected together and then the power produced is connected to the grid, right. Around the world there are many dramatic examples of PV systems also. They include this PV wind diesel hybrid system in Mexico that provides village wide power for 43 homes, 3 schools, 2 stores, a church and an auditorium. You can see the PV panel in this, and then the complete picture depicts the entire description what we have given there, right. So, it powers for 43 homes, 3 schools, 2 stores, a church and a auditorium. Thank you.